To measure pH, the best answers, let's go back to blue. The best answers you've got is either a pH meter or kind of a probe that we've used in school, or you could say universal indicator paper, because that one has a color for every pH, and if we can test the different pHs. Okay, what's the concentration of hydrogen ions in solution X compared to that of Y? So if we look here, how does X compare to Y? Well, Y has a change of pH of 1. Now, if you remember, when pH changes by 1, that means that the hydrogen ion concentration changes by 10 times. So if I go from Y to X, we're going to compare X against Y, so it's going to be 10, it's going to be increasing pH, it's going to be 10 times higher, which is that. And knowing that fact, that core knowledge, helps you to get the answer in that particular question. Okay, next one. I've got an experiment taking place. This is the core practical that you did in year 10. The method is outlined here. State how you could change the method so that the amount of the acid and base can be measured more accurately. Well, they just measured the acid using a beaker. A better way of measuring the acid, or the volume of the acid, would be to use a measuring cylinder, and that would give you more accurate reading. And they're just using a spatula to work out the base. The base is a solid, so a better way of doing that would be to use a balance and actually find the mass of the solid instead. During the experiment, the change is from 2 to 10. Number 2, this is acidic, and 10 is in the alkali region on the pH scale, and they're using phenolphthalein indicator. Okay, so remember phenolphthalein. When phenolphthalein is in acidic conditions at the beginning, then phenolphthalein is actually colorless, and when it goes into alkali conditions, it then becomes a pink color. Okay. Next one, explain in terms of particles why the pH changes during the experiment. So at the beginning, there are lots and lots of H plus ions. So H plus ions, in fact, let's do that the other way around. So at the start, you have got lots of H plus ions, okay? And then during, the H plus ions react with the OH minus ions to form water. So this means that the concentration of H plus ions decreases during the reaction. So it's 2 marks, 2 bits. That equation there, if you remember that equation we just put in, I'm going to underline it in red so you can see it. That is the ionic equation for neutralization. And if you remember, the H plus comes from the acids, the hydroxide comes from the alkalis, and they neutralize each other during that reaction. Okay, right, this next one is one of my favorite questions because you've kind of been a bit of a detective in this. Let me take you through some thinking, and then what we'll do is go through the marks and the answers that are available. Okay, so we've got 4 substances. Let's identify the 4 substances. Now, the bits to know. These 2 contain copper. Copper is a transition metal, so copper is always going to form a colored compound. Sodium hydroxide is a group 1 metal. They always form white compounds, and magnesium is going to be silver. So if we look at the color column first, I can see that this must be the magnesium. This one here must be the sodium hydroxide, and then my 2 coppers are either A or D because they are colored compounds. Okay. Now, you've actually used copper carbonate in class in year 10, and copper carbonate is actually a green color. And I'm going to put that here for a moment. But let's imagine you've forgotten that. What else in this table tells me that it's copper carbonate? Well, the other thing that happens here is when I add acid to it, there's effervescence. That means fizzing. And because this is a carbonate, when it reacts with acid, it releases CO2, and the CO2 is fizzing. This one here must be the copper oxide, because copper oxide is a black colored chemical. And if you come down to here, there is no fizzing because it doesn't contain a carbonate, and therefore you don't get a gas being produced. So that's kind of my thinking of how to allocate these bits to this. The other things probably worth stressing in here is that that is pH 7 and that one is pH 7 because these two do not dissolve. You see here they remain a green solid, so they don't dissolve and therefore they don't impact the pH of the solution. This one is forming a pH of 13 because in there you have got hydroxide ions. Hydroxide ions make it an alkaline pH, and that's why it's increasing in that way. Magnesium, hopefully remember, add magnesium to water and you do get a few bubbles forming on the surface, so that links in with that one. And you also get fizzing when you add a metal to a acid because hydrogen gas is being released as well. So to get the marks, now I've written these out, but I'm going to take you through each one in turn. So for compound A we've identified, and each bullet point here is going to get you a mark on the mark scheme. So copper oxide is bullet point A. Copper oxide is black. It's insoluble, so therefore it doesn't dissolve. This means the pH of the water doesn't change, it remains at pH 7. I can then show an equation here for the reaction with sulfuric acid. So copper oxide with sulfuric acid, this is a neutralization reaction, so I get a salt and I get water forming. The copper reacts with the acid during the neutralization reaction, and copper sulfate is formed, which is a blue colored solution. If I go back up to the table 1 second, I can see here I'm getting this blue colored solution. Okay, so there's the bullet points for A. If you want to pause the video there to tick them off, you can do. Then we've got B. B we said was magnesium. So what makes it magnesium? It's silver. It produces bubbles in water, and I can show that through this equation. So magnesium plus water makes magnesium hydroxide, and then hydrogen is being released. Bubbles are hydrogen. The magnesium hydroxide is a base, so it's slightly soluble. And that means its pH is 8, but it's only very slightly soluble because bases don't really dissolve very well. The magnesium reacts with sulfuric acid to make magnesium sulfate. So as a metal plus acid makes a salt, and the gas hydrogen is released as well. And that's why it fizzes. And magnesium sulfate is colorless, and therefore the magnesium reacts and disappears. Again, pause the video there. You can tick off the bullet points to see how many you have mentioned. Any you've not mentioned, please add them to your notes, to your thinking, to help you. Right, substance C, we said was sodium hydroxide. Why is it sodium hydroxide? Because sodium hydroxide is soluble, and when it dissolves, it releases hydroxide ions, and the hydroxide ions make pH 13. The solution that's formed when it dissolves is a colorless solution, and this is an example of a neutralization reaction. So you've got acid and alkali makes a salt and water. So I'm writing the equation down to show the reaction that takes place. The sodium hydroxide neutralizes that to form a salt and water. We've said that. And the products are colorless, which is another observation from the table. Copper carbonate. Copper carbonate is a green color. It's insoluble as well, so the pH doesn't change, it remains at pH 7. I'm going to show the reaction here for copper carbonate with sulfuric acid. So you get your salt, copper sulfate, you get your gas, your carbon dioxide, and also you get water. So you get 3 products this time for this neutralization reaction because that's a carbonate. During reaction, CO2 is released, so that's the fizzing, the effervescence that they say. This causes reaction to fizz. And then the final little bit is this chemical here, copper sulfate. It's a blue solution. Let's just whiz back up to the table a moment. you can see you've got this blue solution forming again here. Again, pause the video there if you want to check off your bullet points for that. What I've then done is I've just worked out that in total, I think I got 28 bullet points there. And as long as you've explained it logically, they'll then look at how many of those points you've ticked off. So for example, if you get over 24 points ticked off, then you get 6 marks for that particular question. And they'll have some kind of banding to then break you up into number of marks that you've got based on your points.